Hello everyone, my name is Harvey and today I'll be presenting our week 2 sampling distributions mini project with my partner Chloe. Today we will be discussing the proportion of needle spacing out from tossing push pins. This is the topic we chose out of the four given. So first we have our sampling distribution model. So here is our normal model and analysis. After tossing a group of 50 push pins, there are 33 push pins that landed facing up. So our sample size, or n, is 50 push pins. Then our mean is 0.66 and the value of Q is 0.34. And here's our standard deviation. We got our standard deviation by multiplying 0.66 and 0.34, divide that value by 50 and square the whole thing, in which you will get 0.067. And here's our normal model. The red line represents the 68% interval, the blue line represents the 95% interval, and the orange line represents the 99.7% interval. So here are our confidence intervals and conditions. So for confidence level 68% of a sample size of 50 push pins should contain between 59.3% and 72.7% push pins facing up. For confidence level 95% of a sample size of 50 push pins should contain between 52.9% and 79.1% push pins facing up. And for confidence level 99.7% of a sample size of 50 push pins should contain between 45.9% and 86.1% push pins facing up. Now I'll be handing this presentation to Chloe.
So in order to solve for the confidence level of 95%, the first thing that we had to do was identify our z-critical. In order to do so, we used the formula of invert norm and inputted the values on the side in order to give us approximately 1.96. We then took this information and multiplied it with our standard deviation in order to solve for our margin of error, giving us approximately 0.13. However, in order to have more accurate data, we decided to use the full length of the value and add it and subtract it to find our upper and lower interval. For our upper interval, we were given approximately 0.79. For our lower interval, we were given 0.53. So, moving on to our next slide, our confidence interval conditions. So the first condition that we looked at was the independence condition, and we were able to meet that because the value of one observation doesn't affect any of the others. And with the sample size, we were able to meet it because there was less than 10% of the total population of push pins, and the randomization formula was met. Well, because frankly, the outcome was random, there was no bias involved in tossing push pins. And lastly, the success-failure condition was met because both the success and the failure, I guess you could say data sets, were more than 10. So, moving on to the next slide, interpretation and conclusion. With that, we are 95% confident that the true percentage of push pins that landed face up when tossed out of a sample size of 50 push pins lies between the confidence interval limits of 52.9% and 79.1%. With that, thank you so much for watching, and if you have any questions, comments, or concerns, feel free to reach out. Thank you!